Okay, well, good afternoon, everybody. Thank you for being here. My name is Kan, and I'm with Lyngso, and I've got Tracy here from Webb Ranch, and we have a very, very awesome talk about composting and the new Webb Ranch compost that Lyngso is now carrying, and Tracy's going to talk all about that. Before we begin, I just want to give a couple Zoom etiquette tips. Just please do mute your microphones there, and you don't have to be on video if you don't want to be. Probably helpful not to be on it for the bandwidth. Besides that, I think I'm going to let Tracy take the floor and share the talk.
Thanks, Kan. So I'm going to go ahead and just start by sharing my screen. Let me get that up. And all right. Well, thank you everyone for coming to our talk today. If you don't know, my name is Tracy Meskel, and I also want to thank Lyngso for hosting this event. So in my talk today, I'm going to be talking about a specific type of composting, which is the aerated static pile method. And in particular, how this method is really a great way of composting manure. Oops, sorry. Okay, so first I'm going to introduce the team, what I'm calling the compost team, a little bit about myself. I am a landscape architect and have been practicing here in the Bay Area for the past 18 years. And I'm also a member of the Webb family. And that's how I got involved with the compost operation and helped them start it. And I'm now managing it for the family. If you don't know, Webb Ranch is a ranch that's located here in Silicon Valley. They are part of the Stanford lands. And part of the ranch is designated towards horses. And we have a lot of equestrian facilities where we're boarding horses or teaching riding lessons. And then the other part of the ranch is where we have our farming and we do organic crops, which we provide to the public. Another member of our team is obviously the horses. We have about 200 horses on the ranch who provide us with yards of manure every day. So they contribute a lot to our compost operation. The final member of our team is Peter Moon. He runs O2 Compost, which is a compost consulting company. And he's been actually doing composting for 20 years using the aerated static pile method. And he in particular has done a lot of systems using manure and other types of material that can have high odors or problems with the composting and pathogens and that sort of thing. So I reached out to him a couple years ago and said, hey, we have a lot of manure, we need to compost, can you help us? And we brought him on, and he's a consultant for us to help maintain the system. If we have any questions, he's right there, and he is just a wealth of knowledge about this system. So the compost goals that we had going into this, and probably what a lot of people have when they're composting, I've kind of highlighted it here into three categories. The first, obviously, we want to enhance our soil and plant health. For us, we're using compost on the farm fields, and we are wanting to do all those things that the compost is known for, where you're going to enhance your plant growth, you're going to provide food for the beneficial microbes, and also here in California, we want to retain that water in the soil. Another part of our goal is the sustainable aspect of compost. We wanted to reuse our waste material, keep it local and on site, and not have to truck it off the site. And with our farm, we already were not using chemical fertilizers. We've been organic for quite some time, but that's something that's a benefit I think a lot of people look for from compost. We also wanted to meet the USDA's National Organic Program standards. It's not required to use organic compost on your fields to then be called an organic produce. However, it's just one of our goals is to continue to try to promote the sustainability of our practice. The other thing that the compost does is it sequesters carbon, and by putting that into our fields, that's going to help sequester that carbon even better. And Lyngso actually posted a great talk last week, if you missed it, all about sequestering that carbon in your soils. So if you missed it, they have the link. We have the San Francisco Creek going through our farm, and we wanted to make sure that all of our manure wasn't going to contaminate that water and our groundwater. So using a system that would help mitigate any water contamination was an important goal for us too. Finally, for high quality, this really came more from my landscape background and seeing out there all the gardens over the years, and how much the soil really needs to have improvement to it, an amendment. And oftentimes that's probably the last thing that my clients would want to put in and spend the money on, but that's the most important thing for helping those plants grow. So having that high quality compost so you can get the most bang for your buck, so to speak, out of it, that was something that I was hoping to achieve as well. So obviously already having the manure in there, you're having more nutrient quality, nutrient content, that's going to help. But you know, we don't want the bad odors. We didn't want the weed seeds to be spread around. We didn't want pathogens. And later on, we actually had people asking us about, well, you know, I put dewormer in my horse and antibiotics in my horse. What happens to that? And we wanted to make sure that the system we used would degrade all those, so we're not passing it along in our compost. So what is the aerated static pile? What does it look like? So I did this drawing kind of to show the layers of the static pile. And first you start with your base, which is usually like wood chips, something really chunky that's not going to break down really fast. And that kind of goes around and under the pipe. In our case, we have a lot of wood shavings and our stuff is pretty porous already. So Peter Moon was telling us that we can skip that, but for most people, that's something you would want to put down first. Then you have your pipe, and the pipe's connected to your blower. The pipe is perforated for most of the part that's under the pile. And so what happens is the blower shoots that air into the pipe, and then it goes up in through your mix, and the pipe is capped on the end. So then you finally do your raw mix on top of your pipe, and that makes sure you have certain parameters of how tall that can go and how wide. Just really depends on the overall pipe system. And then finally the cover layer. The cover layer is actually one of the most important elements besides putting the air into the system. And the cover layer is usually what, when you already have some finished compost, you just put that right on top of your pile at about a 6-inch depth. What this cover layer does is it insulates your piles so that the temperatures can stay nice and warm for the compost. It helps keep the moisture in as well. It prevents flies and other pests from breeding. And I can tell you, with all the horses on the ranch, we do not like flies. We have way too many. And this is one way we're helping to mitigate that and actually reduce our fly population. And then also the odors that might come from a compost pile, they are capped by that cover layer and helps prevent having any odors escaping, which I know that our neighbors greatly appreciate. So that's kind of the basics of the aerated static pile. Now, this one is just placed on ground. There's ones, much smaller ones that can go in a built bin. So, but this is the one that we're kind of using on our farm. The pros for an aerated static pile are that it's a faster process and it requires less space. And for us, that was a great benefit because, like I said, we have 200 horses making a lot of manure every day. And we wanted to make sure that we didn't run out of space. And we also wanted to compost it faster so we can turn over that compost and get it onto our fields quicker. And then, of course, all the things I mentioned about the controlling odors and flies, pile temperature and moisture levels. This system also qualifies you to be registered for as an organic input material. And that's assuming you meet certain criteria with the temperature, which I will go into a little bit later. But for us, again, we wanted to have something that would make it easy for us and also allow us to register as an organic input material. The cons in a system like this is it does need electricity or a solar power source. So that's something you'd have to add. Like for us, we had to get electricity out to where our compost was. And then you have initial startup which requires the purchase of a blower, a timer, and some pipes, in addition to whatever containment system you might normally be using at, say, home with like a wood bin or something. So there is some initial cost at the startup, but for our system, it doing like windrows or something like that, this is a much simpler and less expensive requirement as a startup. So we're not having to get some really big equipment that would turn the piles. Okay, so I'm going to go over a little bit now how we're implementing it here on our farm. And so this is let me see if I can get the pointer and make it easier. Okay, so this is our mix before it goes on the pipes. We have our manure, our bedding, which is the wood shavings for the horses, any hay that they didn't eat. And then during the summertime and the fall, we also collect any crop residue that we have, like our spoiled tomatoes or our pumpkins that didn't make it out to our pumpkin patch. So that all gets mixed in throughout the year as well. Once that mix is mixed together, you can see we have our system here onto our pipes. For each pile, for us, we have 4 pipes, and that constitutes 1 pile. So our system actually is called an extended aerated static pile, because once one system is completed, we just keep putting on mixture right up next to it and make the next one get started. So we're maximizing our space for composting. And you can see we have, so every pile is almost, every pipe system is about a month's worth of compost. And these are about 80 feet long. Yeah, so you're just seeing one end of it. Right here, I'm showing you our temperature probe, and it reads right now about 132 degrees. So in the initial startup phase of the pile, I'm out there temperaturing the piles every day to make sure that we're maintaining a temperature of 131 degrees or higher for 3 consecutive days. And that's the key to killing off the pathogens, killing your weed seeds, and helping start to degrade any of those medicines that the horses were given. It's those 3 consecutive days that also is required if you're going to be certified organic. So after our piles have composted for at least 60 days, we then go into the mode where we screen it and separate out anything that's still too chunky, or if we get rocks or sometimes trash from when the stables are getting cleaned. And we hire this company that comes out and screens it for us. But that leaves us with a very nice, finely screened compost at the end that's a 3/8 inch size or smaller. And part of that was, again, quality. I wanted something that we can use for many uses and have a nice look to it at the end. The stuff that we call the screen overs at the end doesn't get wasted. We actually use it to put back on top of our compost piles as our cover layer that I talked about, or we'll use it in our field. So you can see here, we had just applied it to our berry patch. And then here in my hand, I'm holding some of the screened compost. And the thing that I'm really liking about this whole system is that it's going from our raw mix to this nice, finely broken down material in 60 days. I mean, that's how it looks after 60 days. Now we continue to cure it longer, but it's already well broken down and pretty stable by a 60-day time. So it definitely composts really fast. Okay, so the mix of your raw material is really important to have that mix just right. And so I'm going to go over that a little bit now. The carbon and nitrogen ratio that you want in your mix is about a 30-to-1 ratio. That should be your goal. And the carbon, oftentimes talked about as the browns. It's like the energy for your microbes, and the nitrogen, it's kind of like the protein for your microbes. And that's what people think of as the greens when they're putting in their compost. Manure itself has its own carbon to nitrogen ratio. So for example, horse manure has a 25-to-1 carbon to nitrogen ratio, which is almost perfect to just stick straight on there onto the compost and just use that purely. In our case, we have all the horse bedding that we're dealing with. So our carbon actually was higher than we wanted it to be in the beginning. And so we had to do some changes where we brought in, we found a new shaving supplier that gave us much smaller shaving pieces. So that way, not only when we're cleaning the stalls, we're pulling less of the shaving out because a lot of it falls through the tines of the fork. Now that smaller material breaks down faster, and it just helped bring down our carbon to nitrogen ratio in that initial mix. Chicken manure, for example, though, has a 15-to-1 ratio. So it has a lot more nitrogen in it compared to the carbon. And so you actually would want to add more carbon to that mix in the beginning. If you have excess carbon, what happens is it results in a limited microbial activity, or it slows the whole process down, and it will take longer to break down. If you have excess nitrogen, you're going to have a compost with more odors and a lot more nitrates, which can lead to water pollution. So in our case, for sure, we wanted to make sure that we didn't have excess nitrogen, because that water will come into your compost pile in the rainy season and leach out and will be too high of nitrates. Bulk density, or in the porosity, it's kind of interchangeable a little bit. The porosity is important because you want the proper flow of air through your mix. And if it's too dense, if it doesn't have enough pores, it's going to be really hard to push that air through your system. And so you want a bulk density, kind of a way to measure it. I mean, I have it here about 900 pounds per cubic yard, but a better way to, if you're at your home garden, is if you have a 5-gallon bucket, fill it with your compost, your pre-mix, and put it, and it should weigh about 20 to 30 pounds. And then you have the right bulk density. If it's too light, then you might want to maybe add some water and more material and see if you can make it a little heavier. If it's too heavy, then you need to add some different bulking material to lighten it up and get some better airflow through there. For example, steer manure or cow manure is quite dense and wet. And so that material, you'd want to add more bulking material, like the shavings or something that's going to help, or more browns that'll help get that airflow through there. Finally, on this page, moisture, the water level is key because you want the microbes to be active and happy, and they need sufficient moisture to do that. So you want that moisture content to be somewhere around 40 to 60%. And a quick, easy way to test that is if you grab a handful of your mix and squeeze it, you should see some water just kind of forming. You're giving it a good squeeze, just kind of forming around the edges of your hand. Maybe you'll get one drop of water to come out, and that's it. Then that moisture content is just about that 50 to 60% range. You should definitely have a sheen on your hand after you've squeezed that mix. If you're dripping a bunch of water out, then it's too wet. You need to add some more dry material. So finally, the final ingredient is the oxygen, which is probably one of the most important ingredients here in this system. So this is the aerobic composting method. Is you want that oxygen there for those microbes to be eating and happily composting away, and that allows that oxygen allows them to keep multiplying and keep adding to your system by breaking all that compost down. And so they use that oxygen, and then they give off carbon dioxide, and that's kind of the byproduct from the microbes. By keeping the system continuously aerobic, you're allowing those microbes to compost 24/7. For example, a lot of you might have one of those systems at home that you kind of go out and you turn, and you're allowing that air to kind of circulate through there and get more into the middle of your pile. Same thing with the windrow systems. They come along and they'll mix, and they're mixing air into that compost as they go through. The thing with the microbes, though, is that they will actually use up all the oxygen in your system in about 30 minutes. So most of the typical systems that are trying to be aerobic actually go anaerobic after 30 minutes. So if you're not adding air every 30 minutes, you're getting periods of anaerobic composting, and it's much slower. So this system at a minimum is putting air in every 30 minutes to keep those microbes multiplying, keeping them happy. And that's why this system composts faster, because you never go anaerobic. It stays aerobic continuously the whole time you're adding air. And again, it's the air that's coming in that is helping you control those temperatures. And those temperatures at a higher level are what eliminate the pathogens, kill the weed seeds, degrade the vaccines, and that's decreasing and overall decreasing the time for your finished compost. So I'm giving you, this is kind of a general timeline of a system. So once you've got your mix and put it on the pile, that's day one. You start your air in your blower. And in that first 2 weeks is usually when you'll get your 3 days of a temperature where it's 131 degrees or higher. And after that, then you can kind of add some air and start cooling down your system. Now, initially when you add air, it actually heats up your system, because what you're doing is giving all those microbes a lot more air and they multiply. And so you'll see sometimes the temperatures rise for a little bit, but eventually that air will cool it off, starting with the bottom layer of your compost pile. And as the heat rises, you'll see how the top parts of your compost pile always are a little bit hotter than the lower portion. So after day 30, your active phase of composting is finished. And so your what's called the thermophilic phase, where it's the higher temperatures, kind of stops. And then you go into the cooler, lower temperature phase. That's the mesophilic phase. By day 60, we've done tests on our compost from day 30 and every month since to kind of just see what's happening. By day 60, for sure, the compost is already stable. Now, what does that mean? So stable is really the resistance of the compost to further decompose. So at that point, your compost is stable. It's not going to keep degrading over time as fast. Obviously, things will continue to decompose over a long period of time. But if you put it in your flower pot, for example, you're not going to see that level drop a ton once this compost is stable, other than the fact that when the air gets squished out just from its own weight. Maturity, however, describes the suitability of the compost for a particular use. So, for example, immature compost can really sometimes damage a plant from the ammonia in it or volatile organic acids. So that's one thing to look for. And there's different metrics that will measure maturity, and I'll go into that a little bit later when I show you some of the tests. For us, we go a full 180 days of curing just based on our tests and what we're looking for in our own maturity for the compost. And we screen it any time between day 60 and day 180 and let it sit and continue to cure. So this is an example of what our temperature monitoring sheets look like. And this kind of gives you insight of what's involved with temperaturing your pile. So this is pile number 11. And day one was, let me get my pointer. Day one was August 2nd. And then by day 3, I went out and temperatured. And you can see we were getting a lot of high heat already by that time. So when we temperature, we actually measure at different depths. So position 1 is on top of the pile, and we're putting our temperature probe straight down into the pile. So at a 1 foot depth, we were at 168 degrees. We were getting up into the almost 180, or at 180 here, which is a little hotter than I would actually like it to be. So then for the next day, I actually increased the amount of air. But you can see here for the middle of the pile, which is at position 2, that's at one end of our pile at a 4 foot height. and we put our temperature probe in horizontally. And so you can see as you get into the deeper parts of the pile, the temperature is always typically a lot warmer. And then at the bottom portion of the pile, this is 18 inches off the ground. And we also go into 3 depths in. And so you can see here, we have our 3 days in a row at least above 131. This particular pile came out pretty warm right from the get-go. And here you can see, so this is how many times it comes on in an hour. So at a minimum, it's always 2 times an hour. So every 30 minutes it comes on. And the duration in the beginning was for 1 minute, and then I increased it to 2 minutes, and then 3 minutes. And you can see here, just by adding that little bit more air, we're able to bring down some of the temperatures here in the lower levels and even here. So we're getting away from the 180 down into the 160s, which is kind of where I wanted it. And this is kind of showing the end of the chart. And so this is week 5, where things are generally cooling down. And I was still, wanting it to cool down even further. We're hitting here in the 150s. And I wanted to see that go into the curing phase more and be in the 120 to 80 degrees. So I increased the time. So it ran for every 20 minutes in an hour for 8 minutes each time. Oops, sorry. So then that got us down to 120, 103, and 88 at the different positions. And so it's at those levels that you start getting other types of microbes coming in and working on your compost. The higher temperatures is pretty bacteria dominant, and the lower temperatures, you can start getting the fungi and protozoa and some of those other microbes to come in and help with the composting. Okay, so lab results. That was another part. What is our compost looking like after we've cured it for a while, and how does it look? And is it doing what we want it to do? So we use a lab in Watsonville, yes, and it's called Soil Control Lab. And it's pretty typical. The labs will give you general, like, what are your nutrients? And they also have a nice interpretation of some of the other elements. So is your compost stable? Is it mature? And again, so they use a bunch of different ways of testing for maturity. And it really depends on what you're looking for. Their cucumber emergence test, for example, is how harmful is it to young plants, or any plants really. So they take cucumber seeds, which are quite susceptible to salts and ammonia, and they plant that in pure compost and see what's your emergence rate. And I think even when we did it at 60 days, we had 95% emergence rate. So we knew that even at 60 days, it wasn't going to be harmful to plants, but we were looking for other elements here. So we've been looking for our ammonia and nitrate to ratio, something we're interested in, our pH value as well. But so that's something that some of these compost tests will give you. And then finally, another important part is it safe? And this measures for pathogens as well as any metals that might have gotten into your mix. And does it have any of that? And so far, every time we've been passing that. So that the ASP system has definitely been living up to what it's promised and providing us with a compost that is getting good values in the stability and maturity, as well as the health and safety. So if you're like me, when I first got one of these tests, I had no idea how to read this. What does it all mean? How do I use that for myself? And so talking to Peter Moon and also finding some good articles online, and one of them I've actually highlighted down here. So when you can get a copy of this, you can look that up. They actually have a good explanation on how to read a compost test, but I'll go over some of the key parts here for you. So we're always looking at the dry weight. So after they've dried it out, gotten rid of all the moisture, that's what we're going to be focusing on, is this column here. So they will give you all sorts of different nutrients, but I'm going to focus on some of the key ones. So nitrogen, that's something. So if you take a soils test at home, and you can use those little ones that do the strips that are kind of based on color, how much nitrogen you have, and it'll tell you, oh, you have a lot of nitrogen, you're okay with nitrogen or you're lacking nitrogen, you can then use this as a way to decide what compost you're going to buy. So if I was low on nitrogen, I would look for a compost, if I could find one, that is actually at least between 1 to 2% of the total nitrogen, because then, you know, I'm not taking any nitrogen out of my soil, and I might just add some nitrogen with it. Or I look for a compost that has greater than 2%, and then it can be actually a fertilizer source. Most of the compost that you'll see out there, the readily available nitrogen is coming from the inorganic form, and the inorganic form are the ammonia and the nitrate, and it's never very much in compost compared to the amount of organic nitrogen, which will break down eventually, but it's not readily available for your plants. Phosphorus, you know, again, standard ranges here for a compost. And I will say that after reviewing quite a few different kinds of compost out there, green waste compost might be pretty good with their nitrogen, but they tend to be a little lower in the phosphorus and the potassium. So if you're looking or you need something more for your phosphorus and potassium in your soil, looking for a manure mix or manure type compost, that's going to give you more of that than your standard just green waste compost. The pH. So again, most plants are happy with anything in the 6 to 7.5 pH range. And even if you have acidic loving plants, I wouldn't be too concerned about putting a compost down if you're just adding like a thin, 1 inch or 2 inch layer just to help feed the soil. But if you're really working hard on getting those hydrangeas to be blue, or you're just putting your blueberries in and you know that your soil needs to get more acidic, then I would recommend looking for a compost that has at least a 6 or even less if you can. I think the Diestel one that Lyngso sells actually is fairly acidic, which is great for those kinds of plants. And then for everything else, most composts that you see come in that, I would say, 7 range. Organic matter is actually quite important because that's why you're actually buying the compost. It's to feed your soil with that organic matter. So you want to make sure that what you're getting has a good amount of organic matter in it. And so you're looking for something in the 40 to 60% range of organic matter. And but one thing I will note that I found out is that if it's showing higher than 65%, so here's your number organic matter here, ours is 56%. But if you see a compost that's higher than 65, it might be a sign that it's not composted enough and it's a little unstable still. If it's below 40%, you're getting into 30% organic matter, you probably actually have sand or dirt in that mix, and it's not 100% compost. And then finally, the carbon to nitrogen ratio. This helps you kind of also, again, look to see how much nitrogen is available for your plants. If it's less than a 20-to-1 ratio, then you have a nitrogen that's going to be readily available. If it's in that 20 to 30 range, then it's going to be pretty neutral and may or may not give you nitrogen right away. And if it's above 30, then you want to add nitrogen if you're going to use that compost, because it's going to immobilize the nitrogen that's in your soil and in that compost, because it just has too much carbon, and the microbes in your soil are going to need nitrogen in order to break that down further. One thing I will note is the CN, the carbon to nitrogen ratio, is not always a sign of maturity. You can have a CN ratio of, like, say, 15-to-1. And if it's really heavily made up of greens, they will automatically show a high carbon to nitrogen ratio, but they might not be composted. So you need to look at other factors if you're looking for something that's composted well enough and is stable at that time. Okay, so when we first had our compost get done, we wanted to do some tests actually in the garden. How is it doing? How's the garden reacting? Is it doing what we want it to do? So I fortunately had a nice patchy spot in my lawn that I needed to take care of. I even had aerated it over the springtime, and because my kids in the backyard do a lot of soccer and play around, my poor lawn gets beaten up quite a bit. So here's my patchy spot that I used. I put down about, I think it was just under an inch, or sorry, ½ inch of compost on the lawn right there. And then I covered it with a wire mesh cloth just so I could find it again, make sure I knew where that spot was. And I also took a shovel full of the dirt out and just to see what's going on underneath. And so the roots pretty much stopped right about here, which is about 3 inches down. Even though my moisture, from watering, because I had watered it just the night before, was well further down, at least to 6 inches deep. So something was going on where my roots were not happy and the plant wasn't going as deep as I'd like it to. So then I kind of walked away. I didn't touch it with my watering time. I think I mowed it once because I generally keep my lawns 3 to 4 inches tall. And so I came back 23 days later and this is the results. We had the filling out, the blades of the grass grew a lot taller. And if I didn't have the screen there, I might not have actually found the spot again. I was actually quite happy with the results. And then I took the shovel to find out, how's it doing with the roots? And you can see a lot more roots coming down here now and into the 5-inch depth level. And actually in this time, the schedule for watering wasn't due to water until later that night. And you can still see here that there's still moisture content in that upper 2.5 inches. And I attribute that to 2 things. One, the grass blades being taller and shading the lawn, as well as the compost acting as a nice moisture barrier. We also decided to give some compost to some avid gardeners. So we got the help of the Portola Valley Garden Club to come out in May, and they took some 90-day-old compost that was not screened, and we wanted them to test it on their gardens. And they came out and they put it wherever they wanted to put it. So some put it on their vegetable beds, some put it on their lawns, around their roses, around the fruit trees, around their just regular regular perennial beds, and went to town with it. So 45 days later, I sent them a survey asking them for the results. And overall, what I was looking for is the compost really enhancing and helping those plants in the gardens improve? And I would say overall, our feedback was yes, we were getting good growth, more flowers and fruits, and everything was looking healthy and greening up. Okay, so now just kind of looking at our goals and what did this aerated static pile system really accomplish what we set out for. So looking at the soil and plant health, our organic matter levels were very high. We're finding good nutrient levels in our compost. So we're really happy with that. Sustainability reasons, we definitely were not having water runoff that was contaminated. The system, the way the mix is mixed and everything else, all those nitrogen, phosphorus, potassium is getting bound into that compost, and the microbes are working away and doing a good job with that. And we're also able to reduce the amount of our waste in a short amount of time. So our manure before would just pile up and not break down very fast. And now we have, we're able to manage much more manure in the same area than we did before. In fact, I have a good story to tell about that, where we're trying to make our piles about 8 feet tall. And my brother-in-law went out to go look at the compost piles, see how they were doing, and he noticed that one of the piles was looking about 5 feet tall. So he said, "Hey, is there a way we can get these piles taller?" And so I went out and looked at it. I said, "Well, that's the one that's composted. It was 8 feet, and it's dropped down by 3 feet as it's composted down." And so that was a nice surprise for them to see that this waste that was taking up so much space and was becoming a liability was composting down to a smaller amount. In fact, now I'm joking with them that we might not have enough to put on our fields and support and give some to the public. So, and then finally, the high quality. We're passing our lab test to the amount that we're happy with, and we're getting that to the levels we want. And we've had successful trials with our local garden clubs. So bringing this around to the public, is this aerated static pile method the right method for you? And I would say that if you have a lot of material that you're trying to manage, and you don't have a ton of space, then this absolutely is a great product or a great method for you to use, because like I said, you are composting continuously with the aerobic method, and it breaks down a lot faster, and you're able to turn over your compost and get it out into your garden a lot faster. If you have manure and you want to treat that and not have to deal with the smells from it and all the other aspects that come with manure, then this system also is a great way to compost that. I know a lot of sites around, or a lot of facilities around us are trucking their manures off-site, so it's a big cost and a liability for them. This is a great system that can help keep that manure on site and use it, and then be an asset to the rest of the community. It also is a great way to manage the health aspect for manure. So typically you don't want to put your manure into your soil any sooner than 120 days from harvest, from before harvest, so that you're not contaminating your food with the potential pathogens that could be in the manure. So that's a limiting factor if you're going to use manure currently in your gardens. With this system, you kill those pathogens, and you don't have to be worried about when you apply the compost in relationship to when you want to harvest that food. I think for any public entity, schools or restaurants, corporate campuses that have a lot of food waste, and they have a landscape that they can use that compost on, this is another great way to do it. That again makes a fast compost that also is safe for the members of the community to be around or to eat food from when it's grown in the compost. Okay, and then so I've listed some contacts if you have further questions for me, or wanted to look more into the ASP system. And also I have Peter Moon's information here, as well as some additional aerated static pile resources that you can read about, including this book here that is a smaller book. I think it's about $50 to buy it. And the guy goes into the aerated static pile system. So if you're kind of a do-it-yourselfer and want to kind of try and make your own system at home, I would recommend this book as a starting point. And I will go ahead and I'm going to stop there and open it up for questions. Okay, so, but I appreciate everybody taking the time here to listen today. So but now go ahead. If you have any questions for me or about the system, I'm happy to answer that.
There are quite a bit of questions in the chat here.
I just opened it, yeah.
Let's see.
Okay. So, yes, so the, I believe, Kan, that the slides will be available after the class. Right, okay. And the rotating tumbler screen, that's called a trommel screen that we used. Let's see. Yep. And there's different ones out there. Unfortunately for us, there's not many choices to rent one. I would actually, there's some different ones to try, and you can look at ones you can even make yourself online through YouTube tutorials. Let's see. Where do you take the temperature in the pile? How do you make sure that the outer part of the pile is up to temp and not just the middle? So I don't know where this came into the equation of my talk, but I'll just kind of briefly hit that again. So first, that's where the cover layer actually is quite important, because that way it helps insulate. So that six inch layer of cover layer is keeping the temperatures in. And so when you put that temperature probe in, even within a foot in from the outside part, you're hitting 131 degrees or higher. So that's how you know that the outer parts of your pile are actually warm enough and not just the middle. So that's, if you want, you can ask further questions about that. I hope I answered that. How much should a gallon weigh? That might be the 5-gallon bucket, I'm assuming, when I was talking about that. So if you have a 5-gallon bucket of your mix ready to go onto your pile, it should weigh 20 to 30 pounds. So 1 gallon, if you just say the 30 pounds, it would be a 6 pounds for a gallon. Let's see. How do you make sure that your pile is moist all the way through when you're not turning it? I imagine that the material near the pipes where the air is coming through might dry out. Okay, so good question. So you've pre-mixed and you've made sure everything, all your compost material is thoroughly wetted through. So that's the first part. You have to make sure that you've added water and mixed it enough before you put it on the pipes so it has even moisture. Then when you put it on the pipes, the bottom area, you would typically would dry out more. But if you think about it, and this is just from my own experience too, as the compost pile sits there, it actually starts, decomposing, coming down, and the weight is pushing down. And we've actually had water coming out of our pipes at the bottom. And that's showing that it's almost like squeezing that water down. So we have almost sometimes too much water in the bottom of our piles. And we've had to deal with that by adding more air to try and dry it out. And that's also kind of in the rainy season. So if you can, you actually want to try and cover your piles to prevent it from getting too wet. And when we pulled off the material, because of the weight and the water just getting kind of pushed down, we've always found that around the pipes, our material is actually the wettest, purely from the action of it pushing down and the water draining down. It's also, you can manage that with the temperature. So if your material is too dry, you lose your temperature. Your temperature starts dropping quite quickly. So if your temperatures are high, the bacteria are being active and they're happy they have enough water. So that's another way to check. We've had situations early on when we didn't have a section that got enough water. And so we actually had to kind of deconstruct part of the pile, throw some water on, and then by reading our temperature gauge, we knew it was wet enough and that things were active and happy again. Let's see. Could you please repeat the name of the soil testing company? So that's Soil and Control Lab in Watsonville. Soil and Control. Oh, someone wrote it. Okay.
Thanks.
Yeah. Do you ever test for microbes in the compost, such as bacteria, fungi, protozoa, and nematodes? So yes, we recently did a test of some of our earlier piles. And what we found, because our piles are not getting turned, so we would hope that we'd have more of those bacteria and fungi and protozoa active. What we found is we did find some protozoa, but our bacteria levels were most dominant. And that's just after kind of going, well, why is that? There's a couple of reasons that it could be our mix is not super diverse. We have, like I said, just the manure, the shavings, the hay, and then whatever we get from our fields. But it's predominantly the manure and the shavings. But I suspect more that it's our temperatures. Generally, our temperatures are running high. We're easily staying 140, 150 degrees for a long period of time. And so I'm actually now working on bringing those temperatures down to a lower level, closer to the 100s, so that these other microbes can become more dominant, like the fungi and protozoa. So it's too soon to tell. I'm just starting to make that adjustment. And I suspect that that's what will happen is we'll get more of those populations because we did have some, but the bacteria was by far the dominant, and they're the ones that can handle those higher temperatures. Okay, do we test for antibiotic and vaccine residue? So the Soil and Control Lab doesn't have a test for that. I think we'd have to find a specialist to do that. But I do have some good articles that we can put out there for you guys to read if you're interested, that shows they've actually done trials of this to show how having the aerobic systems with temperatures that are at a nice higher temperature does break those down by almost, I think, 95% in that first 30 days. And so if you're continuing on anytime after that, their conclusion was that you've basically degraded those antibiotics and vaccines to the point that they're no longer, in there. But we do have some good articles, some tests that were done, some studies on that, and we can post that with the rest of the literature afterwards. For larger home gardens with a good amount of compostable material, is there an alternative for providing air that doesn't require electricity and a blower? I've heard of multiple pipes with holes installed throughout the pile. Does this work even if not as well? So I know what you're talking about. There's some where you can just allowing more passive airflow through your system by putting a pipe even through like the center with some holes. I would say that that could help because usually these passive systems, they're small enough that you got a lot of surface area. So you're getting a lot of air passing through around that part of it. It's just the center of the pile that you really need to get to help with the airflow. I just don't know how it compares as how much speed it's doing compared to the ASP system. But I would say I've seen those, and I do think it does. If your piles aren't too big, if you're talking about like a yard, 3 by 3 by 3, and you stick a pipe in the middle, it's definitely going to get some air to the middle part that you're not having to go out and turn. I've heard that depending on the source of hay for feeding the horses, some hay may contain herbicides that could be detrimental to some plants even after composting. And I'm glad, I think it's Pierre, brought this up because this is something that we actually have looked into for our own compost because I have it written down. I'll have to put the name. There's an herbicide, and I can't think of the name right off the top of my head. So that there are some hay suppliers or in some pastures or in some orchards that they'll spray to kill the grasses. And they have found, they first saw this in Washington where it wasn't degrading in the compost. And then it was affecting people's gardens, particularly the legumes and nightshades. And we grow tomatoes, and that's a nightshade. We definitely didn't want that on our field. So we looked into that. We contacted our hay suppliers for our horses. And we primarily supply hay, grass hay. So that person doesn't put anything on their grass hay. So they were cleared. We also supply alfalfa, and alfalfa can't have this herbicide put on it because it would kill it. And so the alfalfa is good. And then finally, when we do have oat hay, I checked with that supplier, and they don't do the particular herbicide that we were worried about. So we have checked that for our own hay source, but that is something that I would look into if you're going to be getting manure from some place. I definitely would check to see where is your hay coming from? Do they use these herbicides? And I'll list those herbicides for you guys after this. I just don't have it on top. I can't remember the name off the top of my head. I think there's like 3 of them. The other concern would be, green waste that's going to the municipalities. Sometimes, people will spray this herbicide on grasses to kill it off. And so if you're having issues with your nightshades or your legumes, that could be a reason for that. They tend to have a leaf curl. They're a little more stunted in their growth, and it's just not as good of a source. And it just is not breaking down. They're finding in the composting method. What will happen to the temperature of the pile if there's too much moisture? So if there's too much moisture, it's, I don't, let me see if I have something in my notes. I don't recall if I've ever had that problem because we're trying to not put too much moisture in the beginning. But I think it's going to make it a little bit more, the porosity is going to be not as good. So you're going to get a little more anaerobic and it'll probably not get as hot because you're not able to push that air through. So if you have too much moisture, the best thing to do is to run the air as much as you can for as long as you can to help dry it out. And then you'll should see those temperatures starting to rise again. But my inclination, is that it's going to start cooling off only because the air isn't getting through. A good way to see that actually is if you're out there in the morning times, you will see mist or like the steam coming off of the piles, and you should see an even steam coming off. If you're like one little section has steam coming off and not another, then you know your airflow isn't coming out evenly. Peter Moon actually supplies a smoke test so you can put it through your system, and it's kind of similar to what a plumber might use in your house to test for leaks. You can do the same thing with a compost pile to see, do we have any gaps in our system where we're having problems where the air is coming out more in one end than the other. Let's see. Does the oxygen from the pipes make its way through the whole pile? I've read that methane tends to be produced in anaerobic situations. I'm wondering if there might be some methane produced if there are pockets where oxygen isn't reaching. So from the work I've done with Peter Moon and talking to him, it really comes down to the size of your pile compared to, where it is on the pipes, how much is on there, and the pressure in your pipes and the porosity. And so that's where someone like him, having done this for 20 years and studied it and really looked at that, he's looked at how much you can put on those pipes and how far of a reach can that air get. And so all I can say is that it's kind of a engineering situation where you want to make sure that the pressure can reach and expand enough through your system. So it does get through the whole pile. And again, like I said, if you do like that smoke test, or if you go out in the mornings, you can see the steam coming off. That's a sign that the air is coming through all parts of your pile. So I guess that's the best I can do on that question. But if I can always look for more, if we can look more into that, I would say Peter Moon would be the source to go to for that. I have mushrooms growing on my pile. Would that be a positive or a negative sign? From what I understand, it would be a positive sign that you're having the fungi growth there, and that it's helping break down your compost. Can you speak to the mechanical needs of your system as far as a tractor and what size and any other equipment? So for us, being a larger pile, we have a tractor and that's about it. With a decent sized loader bucket is helpful. Ours is about a 1 cubic yard loader bucket there. And other than that, that's all we use. And then the pipes and the blowers. For someone at home, they wouldn't need that because you could build a little container system and just use your shovel to put the stuff on and off. But for us, that was also another reason why we really like this system, is that we didn't have to then go out and get that special equipment to turn the piles every 3 to 5 days. Now we do rent the screener, and that again is more not because we were worried about putting stuff in our fields, but for a commercial product, we wanted to have a finer material. I pick up pails of manure off of Kenyatta Road where people walk their horses and put it in my small plastic bin, mixed with kitchen scraps, leaves, and some soil. No grass or other greens. How much manure should I add? Well, the horse manure is, like I said, a 25-to-1 carbon and nitrogen ratio. So if you just wanted to compost straight manure, that's almost a perfect mix for putting it on the pile. Now you're doing kitchen scraps, leaves, and some soil. You know, I would say that you can have anywhere probably about 75% of that manure, and then on down from there, because of the kitchen scraps and stuff, you've got plenty of nitrogen in there. I would just say go make sure if you have whatever you're doing with kitchen scraps, have at least an equal number of greens, if not a little bit browns, if not a little bit more. Cloppy, I don't even know how to say it. Cloppy rallid. Yes, I think that's that sounds familiar. I think that's one of them. And for the herbicide, I think there's a couple others. I want to say bromine just came to mind, but I will look it up. Our sources of hay that doesn't use herbicides. So I looked into this like a month ago, and because I'm not involved in the barn side of it, I don't have the names of the suppliers off the top of my head, but I can get you their names and add that into our just recap notes for people. So let me write that down, make sure we get that. Okay, and I'm gonna get the name of the herbicides, because I believe there are 3 of them that can be of concern. Is there a recommendation for timing of this compost on vineyards, dormant or spring after most rains are over? So I personally would say, for me in my own garden and for people who want to put compost down, because of our climate, fall and early winter, best times to put your compost down without having to till it in, because those rains will help get some of those nutrients down into the ground. If you're going to be mixing in the compost into your soil and really tilling it in, then any time of the year. But because if you want to just kind of lay it out like we did with our berry fields, we did that now so that we can take advantage of our winter rains, really helping that soil and the microbes get all those nutrients coming down into it. So yes, I think before rains was when I would definitely try and put it in. What does the pipe look like? How many air holes and what are their diameters? For our system, we're using a 4-inch diameter pipe, perf pipe. And the holes are only, there's a set of holes on 2 sides. So if you think of a clock, one's at I think it's like a 9 o'clock and 3 o'clock position. Yes. So, and then they're spaced, I want to say every 8 inches. It's some standard pipe that you just would buy a perf pipe at the store. It's not like we drilled them or something. And then it's, and based on what Peter Moon had worked with us and how much we're putting on our pile, we have a certain amount of length we're able to do, which is 70 feet. And so much past the pipe, which actually is quite far. It can go because if you think it's more of a pyramid kind of shape, the bottom layers aren't having to deal with it. They get a little more passive air coming through, and the pipe doesn't have to push up as high. So at the very ends of our piles, we're out about 6 feet away from the pipe. But otherwise our pipes are about 4 feet on center, and that helps give an even distribution of air throughout the system. Okay, so dimensions of each pile, which I kind of just hit. So basically, if you think of a rectangle for the base, it's 70 feet by 20 feet. And then our height can be anywhere from 6 to 10 feet with that. But again, it's not a perfect box, so it's at a 45-degree angle from the base up. Cost estimate to build your system. Well, so the blowers, these are like bounce house blowers. I mean, they're not super high tech there. And that's the nice thing about it too. For the horsepower that we needed for our system, I think we got a 1.5 horsepower blower, which is like $150 or something for the blower. The timers, so you can buy timers off the shelf. Peter Moon has over the years kind of found ones that he likes for consistency and durability. And I believe that timer that we kind of bought through an electrician that he works with, I want to say it was about $200 for that timer. But we've had zero problems with it in the full year that we're working with it. So we're really happy with that. And then the pipes. So once you get the initial manifold, that's the pipes that are connected directly to the blower. And our scale, I'm trying to think, I want to say it was about $500 to buy all the pipes for about 4 piles. And then we reuse those pipes as much as we can. So at least we can get 2 uses out of the perforated pipes, because if you think about it, you got a lot of heat and weight. And so when our pipes start out, they're perfectly round, and by the end, they look like a sandwich. They're definitely a lot flatter. So we get at least 2 uses out of those pipes. And so then, but on a home system, you're not having that, you're not gonna be 10 feet tall. You definitely should get reuse of a pipe every single time. And sometimes our tractors squish it too. So that's, human error. So I think for a home system, I know, for example, Peter sells one. It looks like that. I think I had a picture of it. It has a wooden box and had a little blower and pipes. And with his help, obviously, the training manual. The whole thing was $700. And that's with him being your consultant. So the actual materials probably is much smaller on that. And our temperature probe, the 3-foot long one, you can buy online, and they're about $90. Do you have capacity for more raw local manure from my horse friends? So that's something that I have a goal for, is that being at Webb Ranch with all the horses around us, we know a lot of facilities are just dumping their manure, and that's a goal for me, and also I think for some of the family members on the ranch, is to get the system going to the point that we could take more from other people. And so I would say, yes, at some point we would be looking to take on more raw local manure from people. And if for whatever reason we couldn't, I would, I'm going to be trying to reach out to other friends in the horse world to help them kind of get a system set up so we can be reutilizing this in our community and not shipping it off to the dump. So for my small composting system, I still have a significant amount of dried fecal balls keeping their shape. If I use this compost, should I expect benefits from it, or should I break these fecal balls? So even in our screening, when we screen it, we will have some of the manure balls that have not broken down, and but they've been heated through. So you will still get that benefit. They're just not as pretty. And so, if you want, stick it deeper into the soil or into your vegetable bed, but yes, they will continue to break down and you will get benefits from it for sure. So yes, and Wheeler Farms, we know them. They actually used to be at our ranch, and then he moved off. And so that's why we ended up having to take on our own composting situation. So yeah, Wheeler Farms also does horse manure compost. Okay, so I think I've gotten through everyone's questions, and hopefully I answered them enough. If not, if you guys have anything else, I can answer that now. Otherwise, we can end, and we'll get more of that information posted for you. Well, thank you guys, and thank you for listening, and I hope you enjoyed the compost lesson.
All righty. Thanks everyone for attending, and I'll be emailing out the link for the class here today, along with the PDF copy of the slides. And thank you, Tracy.
All right, and thanks, Kan, and thanks, Lyngso or Kan, for helping to set this up.